Hello everyone, I welcome you all to my YouTube channel. So this is the third part of the question series of Class 10 Maths Polynomials chapter. If you haven't watched my previous videos, you can go and watch that. First, I'll put the link in the description box. So I'll be covering 4 questions in this video. So let's start. The first question is, you are given this polynomial 6x4 plus 8x cube plus 17x squared plus 21x plus 7, and this is divided by this polynomial 3x squared plus 4x plus 1. Given the remainder comes out to be ax plus b. So you need to find a and b. So this was asked in your board exam CBSE. So the solution is as follows. So we are dividing this polynomial by this. So I use the division algorithm. It's simple division algorithm. You can multiply the terms term by term. So you will first multiply by 2x square because it will give 6x to the power 4. Then further multiplying this by this and will give me 8x cube, and this by this 1 by 2x square will give me 2x square. Then I'll reverse the signs and continue the process. You must be knowing the division algorithm by now, so you can pause and watch the solution, right? So on at the last step you'll get the remainder as x plus 2, and we are given that the remainder is of the form ax plus b. So what we'll do now, we'll compare the remainder. So given remainder is ax plus b and what we have obtained is x plus 2. So equating both of them, we'll get a as 1 and b as 2. It's simple comparing, right? So you get the values of a as 1 and b as 2. So this is the first question. Now we move to the next question. The next question is, if the zeros of the quadratic polynomial ax squared plus bx plus c, where a is not equal to 0, this is obvious because it is a quadratic polynomial, and c is also not equal to 0, are equal, the roots are equal, then you need to choose one of these 4 options. C and a have same sign, C and a have opposite sign, C and b have same sign or opposite sign. So this question is from your R.S. Agarwal book. So the solution is as follows. It is given that the polynomial has equal zeros. So the discriminant will be 0, because for equal zeros, this is the condition that discriminant is 0. Discriminant is b square minus 4ac. So b square minus 4ac is 0. So b square equal to 4ac. Now b square will be a positive number. This is very obvious. Take any number, square it, it will always be positive. So b square is equal to 4ac. Since b square is a positive number, so 4ac is also a positive number. So AC will also be a positive number because multiplying with 4 will not affect the sign. If 5 is a positive number, 5 into 4 is also positive, right? So AC is positive, then 2 cases arises. Both A and C are greater than 0 and both A and C are less than 0. These are 2 separate cases. Let's deal it independently. Suppose A is greater than 0 and C is greater than 0. I'll take an example. A is 2, C is 3, suppose. So 2 into 3 is 6. So AC is greater than 0 when both are greater than 0. Or both are less than 0. Suppose A is minus 2 and C is minus 3. So minus 2 into minus 3 is plus 6, which is greater than 0. So these 2 cases are possible. So A and C have same sign in both the cases. Either both will be positive or both will be negative. So you choose the option A and C have the same sign, right? So second question is completed. This third question is a trickier one, so watch it carefully. Determine the zeros of the polynomial, this one. Under root of x square minus 4x plus 3 plus under root of x square minus 9 minus under root of 4x square minus 14x plus 6. This entire is the polynomial, right? Looking quite tough, right? So let's move to the solution. X square minus 4x plus 3 can be factorized like this. 4x I have written as minus 3x minus x, and then I have taken x common, x minus 3, and from here minus 1 common, so x positive sign and minus 3 is left. Now I take x minus 3 common, x minus 1 is left, so this polynomial is factorized like x minus 3 into x minus 1. Now x square minus 9 can be written as x minus 3 into x plus 3 using the identity a square minus b square is equal to a minus b into a plus b. This can be also factorized like writing 14x is minus 12x minus 2x. Then I further take 4x common, and by simplifying I get x minus 3 into 4x minus 2, right? So I have factorized all the three these subpolynomials in this, right? So I'll substitute it back in the original expression, this one. So substituting this, I get this. First polynomial is substituted x minus 3 into x minus 1. Second is x minus 3 into x plus 3, and third is this. Now you see x minus 3 is common in all of them. So I'll take it out with, and under root sign will come because it is under the under root sign. So x minus 3 is taken, and we are left with under root x minus 1, under root x plus 3, and under root 4x minus 2 with a negative sign, right? So this is product of two quantities. This is one number, assume, and this is another number. So either this will be 0 or this will be 0, or both of them will be 0. Suppose this is 0. So under root x minus 3 is 0. So x equal to 3 will be the solution, right? Or the other case is this thing is 0. So this will be equal to under root of x minus 1 plus under root of x plus 3 minus 4x minus 2 is equal to 0. I have taken this on the right hand side and obtained this. Now SBS means squaring both sides. I'll square both sides, and on squaring both sides I'll get, first I'll square the left hand side. This, assume that this expression is A, this expression is B. On squaring, a plus b whole square is equal to a square plus b square plus 2ab. A is this, b is this, 2ab, right? Root and square will cancel, so we'll get x minus 1. Root and square will again get cancelled, we'll get x plus 3, and 2 into this, a and b. A is root x minus 1 and b is root x plus 3, right? So x plus x, 2x, 3 minus 1, 2. So this is the expression on the left hand side, and on right hand side we are getting this on squaring. Root and square will get cancelled because you see root 5 whole square. For example, I am taking root 5 whole square will be 5, right? So you'll get 4x minus 2. Now take these terms to the right hand side, you'll get this, okay? And now you'll take 2 common on both sides, you'll get this finally. Now you square again, you are squaring both sides again. Now one condition we need to apply is that whenever we square both sides should be positive, otherwise this rule will fail. Suppose this side will be always positive because it is multiplication of square roots. So, and suppose this side is negative, so this is not possible, na? So both sides should be positive while squaring. So x will be greater than 2 before we write a condition here before squaring. And in case after solving x comes to be less than 2, then that will not satisfy this equation here on, because this will become negative and this is positive, right? And now I square both sides, simplify it, multiply it. Simplifying, I get x equal to 7 by 6. It is around 1 point something, right? So it is obviously less than 2. So this will not be a solution. I have written it here also, because this side become negative and this side is positive. So they both can't be equal. So the only solution is we obtained is x equal to 3. So the 0 of this polynomial is x equal to 3. You can put and check also, right? So this was not a tough but a lengthy question. Some simple calculation was needed. So let's move to the next question. You can try it once before looking at the solution again. Okay. So fourth question, does this polynomial has 0 or not? This is from your HOTS, NCRT HOTS I've taken. So there is a very simple approach. This is a biquadratic polynomial as its degree is 4. So I take y square equal to x in these cases, or it simply means y4 is equal to x squared. This is obtained by squaring both sides, right? So when I take this replacement, I get x squared plus 4x plus 5, because y4 is x squared, y square is x, then x squared plus 4x plus 5. This is the new polynomial. Now in this case, a is 1, b is 4, c is 5. So I find out the discriminant. b square minus 4ac, it comes out to be minus 4, and so it is less than 0. When discriminant is less than 0, it means the polynomial has no real roots. This means x has no real root, but x is equal to y square. We have taken the assumption here. Means y square has no real roots, means y has no real roots, obviously. Because if y square is having no real roots, it obviously means that y is having no real roots. So this polynomial does not have any zero, right? A real zero. Complex zeros may be available, but real zeros are not present. So by this I come to an end of the video. I'll be posting one or two more videos on the polynomials chapter. Then I think all the major questions will be covered, and then we'll start another chapter. Okay, then bye. Take care. See you.